in all these past lectures, like we discussed about general software engineering, right? Like introduction to software engineering. Then we have seen in detail regarding project management, planning, scheduling. And in last lecture, we discussed about in project management, risk management. Now we'll be starting with various kind of metrics which are used by the project manager to estimate the line of code, to estimate the efforts, to estimate the cost. So these all questions are very important from exam point of view. Not only from exam point of view, but these all are very useful. You have to acquire very good domain knowledge about all this, because this will be used to estimate the efforts which are required to be put in for the development of any software, or cost of the software to be calculated, estimated. So that's why these all are important. So today we'll be starting with first LOC matrix, that is line of code, followed by COCOMO, that is constructive cost model, which is used to calculate the cost of the software, estimate the cost of the software. And then we'll see function point matrix, and last we'll see feature point matrix, right? So you can see so many questions from these topics. If you see any university exam question paper, not only from CharuSat, any across the world, these are favorite topics, very important even. So let us start, I think now. So first matrix, what we have to see today is the line of code, right? It's not line of control. LOC in our subject is line of code. Here it is very easy for me if I have to just calculate the line of code which I have already written at the end of the software. Okay. Once I have written all my programs and then I put together all line of code and then I have to say, then it is very easy. But here it is used to estimate in advance. So this line of code means what? Before you start your project, you have to estimate how many line of code you have to total write in your software, which you want to produce. So this is to be estimated in advance, right? And that's why it is difficult. So why it is difficult, all of you are aware, because everybody's programming style is different. Everybody can lay down program in their own way. Somebody can use more inline function, inbuilt function, library function, ready-made packages, and due to that also your line of code is drastically going to be reduced. Okay, because if you use pre-compiled module, this line of code will never be counted in your front end. So that's why it is very difficult to accurately estimate the exact line of code, right? 100% you cannot be correct in this particular case, because no one can predict exactly how many line of code to be written, but it is a rough estimation. So something is better than nothing, and by following this concept, this is a very simple matrix among all the metrics, and it has a little use, but still people are using it, right? So let us start with the first matrix, line of code. So it is simplest among all the metrics, and here we have to estimate the overall project size by counting the number of source instruction, right? Even if the word is line of code, but we have to count the number of instructions, because in a single line you can write in a C language like 3 instructions, then it is your 3 LOC. So even if the word is line of code, but we have to count the number of source instructions. It means how many instructions that you have written. So please remember, either you call number of instructions or code. So here we consider the number of instructions which are written in one line. If you have written 3 instructions, then it is 3 LOC. And we have to exclude or ignore the lines which we have used for commenting and the header lines, right? This we are not counting. Only effective line of code or logical line of code. So commenting lines we have to ignore. So as we have discussed, like accurate estimation of line of code count at the beginning is extremely difficult, right? So the technique what we have to adapt is divide the problem into module, then each module into sub-module, and then sub-module into sub-sub-module. until you can reach to the lowest level where size of the module can be predicted. Right, and then this way now you have to just aggregate all the module from bottom to top, and then now you have to put together all the module, and then you have to aggregate, you have to just add all this line of code, and then you have to estimate the overall line of code that is required to be written for the software. So if we consider CharuSet as an example, okay, so CharuSet is our top module, ERP system or e-governance system. Then under that we have so many faculty. Under faculty, we have a number of institutes like Faculty of Technology and Engineering. We have 2 institutes, CSP, IT, and JSTAR. Again, we have so many programs, right? Like UG, PG, and PhD. Again, in UG, we have 7 branches. So you see that we have to go up to divide the problem into module, then each module into sub-module, then sub-module into sub-sub-module until you can reach to the module where size can be predicted, estimated. This is where you have to stop. And then you have to just add all the modules at that level. Then you have to go one layer higher, and then to the topmost module where you have to simply put together all the line of code, and then you have to estimate the overall line of code. So if you have a past experience in developing similar kind of products, which will always be helpful. Okay. Otherwise, if you are estimating the line of code for first time, then of course there is a huge variance which will be there in terms of actual and what you have predicted. And when you estimate the lowest level, then you just put together at the lowest level, then one layer higher, then one layer higher, and so on. This way, by putting it together, the managers will arrive at the total size in terms of line of code, right? Like 50,000 line of code, 1 lakh line of code. So output is always a numerical value. Okay, so this LOC gives you numerical value of the problem size, and it will widely vary with individual coding style. No one can exactly predict the exact line of code. So the output of LOC or outcome of LOC is always a numerical value, like 35,000 line of code or 32,560 line of code, whatever. The main difficulty is what? Everybody's style of programming is different, right? Because everybody is laying down their code in a different way. So different programmers lay out code in a different ways. So even if I assign you same problem right now, those who are attending this lecture, if I assign you same problem, everybody will come up with the different LOC count if they have to write the program in their own way. Okay, because everybody's logic, their style of programming, everything is going to be different. So for same problem, different programmer, they might come up with different LOC count. Another important thing is what? Any good size should not only focus on line of code or coding. Okay, coding is just only 10% of your software development lifecycle in terms of efforts. The most important phases are what? The SRS means your analysis and design and testing. So your good size measure should consider overall complexity of the problem and efforts needed in terms of specification, design, code, and testing, not only coding, but all 4. Right? Like analysis, design, coding, and testing to solve any problem. You should not only consider coding. Here we just consider only coding and we are not considering the specification, design, and testing part also. So LOC matrix focuses on the coding activity alone, and it merely computes the number of source lines in the final program. And as we have discussed, coding is only a 10% of your overall efforts in terms of software development lifecycle. It is wrong to argue that the overall product development effort is proportional to the program code. Right? And what is the counter argument? For a problem, design might be complex, but the code may be straightforward. Okay, so for certain problem, design might be complex, but the code may be straightforward. So this LOC correlates poorly with the quality and efficiency of the code. We are never talking about any quality parameters about the code like variable naming convention, coding standard, coding norms, indentation. We are not bothered about the efficiency, time complexity, space complexity. Okay. So larger code does not imply better quality. So if somebody is coming with 60,000 line of code and another person is coming with 50,000 line code, we cannot consider like 60,000 line is better. Okay. So this LOC correlates poorly with quality and efficiency. Here we are not talking about quality of code. Here we are not talking about efficiency or time complexity of the code which we have produced. So these all are the shortcomings or disadvantages of LOC matrix. And LOC matrix penalizes the use of higher level programming language. Okay. So if you have to justify this statement, means you can use ready-made function, you can use inbuilt function, inline function, you can use ready-made packages, and due to that your line of code is drastically going to be reduced. So programmers consciously uses several library routines, the ready-made packages, then LOC count will be obviously going to be the lower. And another disadvantage is what? The LOC measures the lexical complexity of the program and does not address the more important issue like logical or structural complexity. So these all are the issues. And because of that, this has very little use with the manager. So a program having complex logic would require more efforts than the program with the simple logic when you really develop the project. And that's why it is extremely difficult to accurately estimate the LOC in the final product from the SRS document, right? But something is better than nothing. So anyhow, it will give you rough estimation, right? And if you have a past experience, then you can have a better prediction of line of code. So it will give you a rough estimation that for this software, this much line of code is required to be written. Fine. And that's why it is having little use to the managers during the planning phase. So remember, this is the simplest matrix, line of code. Okay, second one is important. This is used to estimate the cost of the software. The metric is COCOMO, that is constructive cost model. The full form is constructive cost model, and it is a heuristic estimation technique. Heuristic, the dictionary meaning of heuristic is what? If you improve your future based on your past knowledge or experience, right, then it is called heuristic. So this particular metric has been proposed by a person called Boehm. So any software development can be classified into three categories based on the complexity, right? So this Boehm has classified the total number of software available in this world into three categories: organic, semi-detached, and embedded. And consider the characteristic of the product, like which are the characteristic of the product. Development team, whether we have an experienced staff, inexperienced staff, or a mixed kind of things. And the development environment, right? This is, we have a conducive environment and a political free or politics free environment and all that, where everybody is productive and they can produce work on time. So lecture चालू करो. So this three product class corresponds to like this organic, semi-detached, and embedded. Any kind of application or your data processing programs or application related programs, they will be considered as organic. Semi-detached, like compilers, linkers, loaders, they all are part of utility program. They are falling under semi-detached. And the third is like embedded. This is where your operating system, real-time system, and any software which is tightly coupled with hardware will fall under that category. Right. So you can see that software, first you have to classify whether it is organic, semi-detached, or embedded. Like if you consider this CharuSet application, it's an application program. Here we have only data processing, so you can consider it's organic, right? Any utility program like compilers, linkers, and this antivirus kind, this all falls under semi-detached. And embedded, any software which is tightly coupled with hardware, then you can consider this as a embedded category. So embedded, if your software being developed is strongly coupled with the hardware, then you have to consider this type of software which you have developed is of type embedded. So in exam, if any problem description is given to you, first you have to classify whether the software is of type organic, semi-detached, or embedded. Okay, and accordingly we have a different set of equations. So these three set of categories, they have a different set of expressions to predict the effort. And as we have discussed, the efforts, the unit is person month. And second equation is for development time. Okay, so for all the three category, you have to remember two equations. First is to estimate the efforts, means if a person has to work, then how many months he has to spend, that is called efforts. And the second equation is the overall development time. So what is person month? Person month is nothing but an effort an individual can typically put into a month, right? So one person has to work particularly for 1 month, then it is called person month. And you have to exclude the productivity loss due to holidays, week offs, coffee breaks. This all we have to exclude. This cannot be a part of your actual efforts, right? So according to Boehm, cost estimation should be done through 3 stages. Okay, first is basic, second is intermediate, and third is complete. So let us start with the first, basic. So first we'll see basic COCOMO model, and this basic COCOMO, as it is a basic, you can give it. You can consider that it gives approximate estimation of the project parameters, not exact. And there are 2 equations, so please remember all these equations. So this is a general template of the equation. You can see that my first equation is to calculate effort. So effort can be calculated by A1 into KLOC. Now you see that previous matrix what we have discussed, line of code. But here they have changed kilo LOC, right? So here they have introduced word kilo, KLOC. So if my LOC count in previous metric was 35,000, then here KLOC will be how much? The unit is here KLOC, not LOC. So you have to divide by 1000. So my LOC count was 35,000, then KLOC would be how much?
35.
35, right? So this is what you have to remember. In exam, I'll give you LOC. But in this equation, you have to put KLOC. So most of the time, students in a hurry, they always put 35,000. Then overall answer is wrong, right? So please remember, I am going to give you LOC count, but here in this equation, it is KLOC. So you have to divide by 1000. So A1 into KLOC raised to A2, and efforts, the unit is person month. Now this development time, second equation, T dev, that is your development time, equal to B1. So there is another parameter. Now effort, what you have calculated from first equation. So this value will come here, raised to B2. And the unit is always in terms of months, right? So your T dev, that is your development time, is nothing but the estimated time to develop the software in terms of months. And effort is nothing but the total efforts of one person has to put in a specific month, or if he has to continue for number of months. So here every line of source text should be calculated as one LOC irrespective of the actual number of instructions. So try to see it is altogether different than LOC. In LOC, per instruction we have to consider one line. While here every line of source text should be calculated as one LOC irrespective of actual number of instructions. So this is what is a change. So if single instruction spans several lines, then it is considered as an LOC. Okay. So if you have written one instruction which span 2 lines, then you have to consider this other 2 LOC. So here you see the equation for 3 category of software: organic, semi-detached, and embedded. First, I am giving the equation for effort. So I'm talking about first equation. There are 3 category. You can see that organic, semi-detached, and embedded. So for every category, we have a one equation. So this is my general template. Effort equal to A1 into KLOC raised to A2 PM. So this value of A1 here for organic software is 2.4. This value of A1 for semi-detached is 3. And the value for embedded is 3.6. So what is the difference? You can easily remember. What is the difference between these 3 value? 0.6. Right? So you have to remember first equation value, and then you have to add 0.6. Then it will become for semi-detached, it will become for embedded. Same way your A2. A2 value here, you see that KLOC raised to A2. So here it is 1.05. Then here if you add 0.07, then it will become 0.12. And again, if you add 0.07, then it will become 1.19. So roughly it will not make any difference if you put 1.20 or 1.19. So this is how you can remember equation for all the 3 different categories for effort. Right, like 2.4 into KLOC raised to 1.05. Then you have to add 0.6 for your A1 and 0.07 for your A2. So 3 equations for efforts for 3 different category of software. So BOEM has classified total number of software in the world into 3 categories, right? For data processing application, organic type, any utility program in between hardware and software, then semi-detached, and those which are tightly coupled with hardware, then it is embedded. Same way, the development time, there are 3 equations. So again, the general template you can see, development time is B1 into effort. Effort is what you are calculating from here, raised to B2, and the unit is months. So my B1 value is 2.5, which is constant for all the 3. You can see that. And the effort, what you have calculated from previous equation, which can be a part of here. And here you see 0.38, then you have to decrease this value by 0.03. So it is 0.35 and 0.32. B2 value is you have to decrease. So of course, first equation you have to remember, and then this is what you can make the difference by decreasing value 0.03, and you'll be getting the equation for second category and third category. So you have to memorize all these equations for all the 3 category. In exam, you may be given a description. I may not give directly organic, semi-detached or embedded. You have to first classify that software as either organic, semi-detached or embedded. If it is organic, then you have to take first equation of this and first equation of this. If it is a software is of type semi-detached, then second equation, second equation. If it is embedded, then it is third equation, third equation. Okay. So let us consider one small example. So all of you please calculate this value. Chalo, write down the size of organic software is 32,000 line of source code. So this value is LOC. Okay. So my LOC count is 32,000 lines. And my average salary of engineer is 15,000 per month. Then determine the effort and time required to develop the software as well as overall cost of the software. So here I have already said that it is organic type software. So which equations should I consider? I have to consider first equation, right? So put up this value. Chalo, effort equal to 2.4 into what value should I put? Here what value should 32. I put? 32. So 2.4 into 32 raised to 1.05. Chalo, calculate what is the value in terms of person month for effort. How much is the value you are getting? If you put up this value into this equation, like 2.4 into 32 raised to 1.05, 90 point something you'll be getting.
91.33.
Okay, so roughly I have put 91. Okay, so I have just taken integer value, so 91 person month. Now which equation should I consider for development time? As it is organic software, I have already given. Otherwise, if I give you description, you have to justify and you have to classify that software is of bit type, right? But here the task is simple. So first equation you have to take. So 2.5 into 91 effort, what we have already calculated, is 2.38. So calculate how much is the value of development time in terms of months. Don't forget to put unit, otherwise your 50% marks will be cut. So how much is the value of development time?
13.8.
Right, so roughly I have written 14 months. Okay, so it's any value 0.5 and above, then if you have to make it integer, then make it 14. Now my average salary I have given 15,000 rupees per month. Okay, so 14 month into 15,000. So total my 14 months person has to be engaged, and my average salary is 15,000, then 14 months into 15,000. This is what, if you make calculate this value, then it will be 2,10,000. This is what is the cost of my software. Fine. So this is how you can calculate the cost of the software. So this is how you can calculate the cost of the software. So this was basic COCOMO. Okay, so you see that according to BOEM, cost estimation should be done through 3 stages. So we have talked about basic COCOMO. Now we are going to talk about intermediate and then complete COCOMO. So this was about basic COCOMO. Now there is an intermediate COCOMO. So here we haven't considered any of the parameters. Okay, we consider all softwares, their complexity level, reliability, execution speed, storage space, the experience levels of programmer available in the organization, programming capability, their productivity, their analysis capability, whether the development environment is productive, conducive or not. We haven't considered all these parameters. So if you consider this kind of parameter, like identify at least 15 parameters, and then you have to assign the scale between 1 to 3, and then you have to refine all this estimate what you have done with basic COCOMO. Then you can have a better cost estimation in terms of what we have done with the basic COCOMO, right? So what is the main disadvantage of basic COCOMO? So here the efforts required to develop the product, we haven't considered any of the parameters, but in real world, these all parameters are always going to make an impact. Okay, so whether the software what you develop is having a lot of complexity, whether you want too much reliability, then you can scale 3 out of 3. And if these values all are higher, then of course you have to pay much more higher cost. Okay, if you want good execution speed, then again, you have to pay huge costs. So you have to identify 15 such kind of parameters which will affect on your software development. And then you have to scale the value in the range of 1 to 3. 3 means highest, 1 is lowest. Okay, 2 means average. And this way, if you can refine all this, estimate what you have done with basic COCOMO, then it is considered as an intermediate COCOMO. So in basic COCOMO, we never consider all the 15 parameters. Here we have to identify 15 parameters, and then we have to scale the value in the range of 1 to 3. And based on that, we have to refine the cost what we have calculated with the basic COCOMO. See, we cannot directly jump into intermediate COCOMO unless and until we do the basic COCOMO. So first we have to do basic COCOMO, and then we have to refine the cost with intermediate COCOMO by identifying 15 parameters, and then you have to assign the scale based on the requirement of the project given by the client or customer. And then you have to define the cost what you have calculated with the basic COCOMO. And then the third stage is what? Complete COCOMO. So up to intermediate COCOMO, like basic and intermediate COCOMO, we considered software as a single homogeneous entity. But you are aware software is always can be divided into front end, back end, middleware and all that. Or even if you are aware that large systems can be made up of several subsystems, like if you consider CharuSet ERP also, then we have so many subsystems, like we have an exam section, we have HR, we have accounts. So these large systems can also be made up of several subsystems with different characteristics. Now here, if you want these 15 parameters, what is being written for exam section module or accounts module or HR module are never going to be the same. Okay. So first here you have to divide the software into module, and then you have to assign 15 parameters for each module, and then you have to calculate the cost, or you have to refine the cost. This is called complete COCOMO. So this considers differences in the characteristic of the subsystem and estimate the effort and development time for each subsystem separately. And then the cost of each module is estimated separately. So this is your complete COCOMO, right? So let us see that we have an example of our own system, distributed MIS product or ERP product. So here this will be giving you more accurate result, and it will reduces the margin of error in your final module. So we have a database also, which is a backend. So we consider it is more related to hardware, in between hardware. So it's a semi-detached. Your front end is data processing. So you can consider it's organic, and your communication part, which is happening across all the faculties, is embedded software. So now you see that in a single application, we have all the 3 categories. So you are aware about the equations are also different for all the three category. Now you have to estimate the cost of all three modules separately, and then you have to sum up to give the overall result. Now again, the parameters are also going to be different. Like if you consider, if you are going to refine this all cost what you have done, then here for database, the 15 parameters may be different. For organic part, it may be different, and for communication part also it may be different. Right? So these different parameter values can also be fine-tuned. So this is how you can work for the complete COCOMO. So still there are disadvantages. You can see that it is not accurate. You are aware that your experience of estimating the cost of similar kind of project in past will come handy for making the future projection or prediction. Here he has not given any kind of justification, right? Like why this value is only 2.4, why it is 1.05. So no justifications have been given by BOEM. It will only give you gross approximation, right? But as we have discussed, something is better than nothing. So without this, only we have a subjective judgment and no other option is there. And that's why we have to adapt this. So please see to it again. This cost of the software can be calculated with the help of constructive cost model. It is called COCOMO, which is being proposed by BOEM. BOEM has classified software into three categories: organic, semi-detached, and embedded. And per category, we have a different set of equations for effort as well as for development time. This is general template for equations for effort and development time. Then for all the three category, BOEM has given the equation without any justification why the values have been considered like 2.4, 3.6, 1.12. No justifications have been given. Then for development time also, for all the three category of software, BOEM has proposed three different sets of equation. And this is the way you can calculate the cost by using basic COCOMO model. Then in an intermediate COCOMO, working with this basic COCOMO, people have realized that it is not giving you the exact cost. And for every software, there are certain parameters which are important. So they have considered like 15 parameters, and based on this 15 parameter, the scale value, whatever you are assigning, the cost can be refined. So this is how they have worked for intermediate COCOMO. And then we have a complete COCOMO. So instead of considering software as a single homogeneous entity, we can consider system as made up of several subsystems. And then for all the subsystems, we can separately apply the basic COCOMO model, and then we can refine that value by assigning 15 parameters for all these submodules separately. And then we can refine that cost, and then you put together all, and it will make the overall cost of the software. So this is nothing but your complete COCOMO, constructive cost model, right? So in exam, if it is given just to calculate the cost of the software, you can work up to basic COCOMO, no worries. You have to remember all the three different categories of equations for both efforts as well as development time. And these are the disadvantages. You have to remember it's not accurate, lack justification. It will give you gross approximations only, but we don't have any option. Otherwise, we have only subjective judgment. No objective judgment will be there, and that's why we should adapt it. Next matrix is a function point matrix. So here it will overcome the limitations of LOC, and it can be used to easily estimate the size of the software. You can directly use SRS, your specification, and from that you can estimate the size of the software. So this is much more better than your LOC, function point matrix or FP matrix. So here what they says, okay, so many features means larger size of the software, and every function is nothing but it is always going to take input. So every function when you invoke or execute, it will read the input and it will produce the output, right? So here what you have to compute, number of input, number of output data values, you have to calculate. So it will give you some form of indication that how much size of the software can be there. And the another important part is what size also depends on the number of files with which your program is interacting, as well as how many interfaces that you have provided by which you can raise the query and you can get the answer. So these are the 5 function points. Please remember, how do you calculate the function point? So whatever inputs what we supply is a function point. Output is also a function point, external output, external input. Internal logical files, which are a part of your application. External interface file, this is where you are interacting to get some other information, and then any external person can make an inquiry which will interact with your application to retrieve the information. So you can see that there are 5 components: input, output, external interface file, internal logical file, and external inquiry. These all are part of your function point, right? So there is a weightage. So my first equation is unadjusted function point. Here, these 5 points like number of inputs, output, external interface file, internal logical file, and external inquiry, I have assigned this certain weightage. So you see, input and inquiry I am giving same weightage. Output I am giving slightly higher weightage, but files and interface I am giving weightage of 10. So there is a weighted sum of all the 5 components with the added value. So you have to remember this equation. This is how you can calculate unadjusted function points. Number of input into 4 plus number of output into 5 plus number of inquiries what you can make into 4, number of files, that is your internal logical files, and your number of interfaces, that is your external interfaces file, that is into 10. So number of inputs means group of related inputs are considered as a one input. Like when you enroll for CharuSet, you have entered all 35 fields. So it is not going to be considered as a 35 input. Okay, all 35 together will be considered as a one input. Number of output, the reports what you print, screen outputs, like how many forms you have designed, error messages what you have produced. So please remember, this error messages you produce is also part of output. So your static report, dynamic reports, your screenshot or your forms, right? Your web pages, these all are part of your output. Number of inquiries, these are nothing but the queries what you can make so that you can retrieve the information from the system. Your internal logical files, they are related with your application program. So it's a logical file grouping group of logical related data, your data structures or physical file. And your interfaces is nothing but your system is exchanging the information with the some other file or the file on the other disk. Then it will be considered as a number of interfaces. Then we have a technical complexity factor, TCF. So second equation is what? TCF equal to 0.65 plus 0.01 into DI. Right, and then if you have to calculate overall function point, then first equation, unadjusted function point into TCF. So here this TCF refines the unadjusted function point count by considering the 14 other factors. So try to see that here we have considered 14 parameters, and the scale you have to assign in the range of 0 to 5. Right? So this we consider as a degree of influence. Okay, so here if you consider like degree of influence, if I consider this all 14 parameters, all values are 0, then this value is going to be 0. If I consider all this 14 parameter highest value, because these values can be assigned the range of 0 to 5. If I give all the 14 parameters 5 value, then it is 70. So here you can see that the degree of influence can vary from 0 to 70. Right? Ideally, it should not be 0. Ideally, it should not be 5. All parameters. So for my application, if data communication is moderate, I can give 3. Distributed data processing is there. If it is yes, then I can give 4, 5, whatever. If I want high performance, I can give 5. So this way you have to put the value, and this value in the range of 0 to 5 for this 14 parameters. So highest value can be 70, lowest can be 0. Both are not realistic. So any value between 0 to 70 can be there. Okay, but if you put 0, then this value is TCF is going to be 0.65 because 0.01 into 0. If you put 70, then 0.01 plus into 70 plus 0.65, then it is going to become 1.35. So your technical complexity factor can vary in the range of 0.65 to 1.35. And then you have to multiply first equation with second equation, then it will give you overall function point. Right, so you have to remember all these 14 parameters. This is how you can calculate the function point. And now whatever your function point, per function point, you have to give the cost. Like if you have calculated function point is 32, then 32 per function point 1000 rupees, then overall cost is 32,000 rupees, like that. Right. So this is how organizations also can calculate the cost of the software. One is COCOMO. Okay. So in COCOMO, you require input from LOC. Second is function point. So here you have to consider based on number of features or function. So there are 5 things which are associated: number of input, output, inquiries, internal files, and external interface file. So first you have to calculate unadjusted function point with a weighted equation. Then you have to calculate TCF. This is where degree of influence come in the picture. So you have to put up the value in the second equation, and then that value in the range of this TCF can be between 0.65 to 1.35 based on this value between 0 to 70. And then whatever this value, you have to multiply first equation with second equation. Then whatever your FP is there, per FP, you can take 1,000, 2,000, 5,000 as per your organization's cost formula. This is how you can calculate the cost of the software. Right. And another metric is the feature point metric. So the difference between function point and feature point is what? Here we have considered 14 parameters, but we haven't considered algorithmic complexity. So please remember, if you add the 15 parameter here, algorithmic complexity, and this value in the range of 0 to 75, then it is going to become feature point matrix. Otherwise, there is no difference between the function point and feature point matrix. So in function point matrix, algorithmic complexity, we are not considering. So if you just consider algorithmic complexity and add the 15 parameter in this parameter list, then it is going to become the feature point matrix. Okay, this is if you want to make slightly complicated. Okay, so we have basically 3 kind of software. You are aware that, as I have said, complexity is not being added, but if you add the complexity, like if your simple application, you have to consider the input value 3. So in this equation, you have to put this value equal to 3. Number of inputs into 4. In place of that, you have to put 3 for simple application, right? For average, it is 4. For complex, you have to change by 6. So this value will become 6. So if you add algorithmic complexity and based on that, if you refine this value, then it is going to become feature point matrix. Right. So by default, you can see we have considered this value, average value, right? But if it is complex, then in number of input into 6, number of output into 7, external inquiry in place of 4 or 5, we consider 6 or 7. You see, for logical files, we have considered 10. Here you have to give 15. For interface file also, we have considered 10. Here you can give 10 or 12. So first you have to calculate unadjusted function point. It's a weighted sum. Then you have to consider these 14 parameters and calculate degree of influence. And then you have to put this value in this equation of TCI. That is your technical complexity factor, TCF. And then you can multiply unadjusted function with TCF. Then you will be getting overall function point. Right. So as we have discussed, in a function point matrix, we do not take into account the algorithmic complexity. It assumes that the effort required to develop any 2 functionality of the system is same, which is not true. Right. So as you are aware, efforts widely varies from different functionality. 2 different functionalities never require same kind of efforts. So here it counts the functions without distinguishing the difficulty level. So the extension is feature point matrix. So here we have to incorporate extra parameter called algorithmic complexity, and more complexity of function means more efforts are required. Right. So here the size should be larger compared to your simpler function. It is a language independent. When you are using function point, we are not talking about Java, C++, .NET. It's a language independent. You can easily compute from your SRS. But again, you are aware that as per your perception, different engineers may come up with the different function point measures for the same problem. because one person can consider all data as a one unit, another can consider as a number of units. So these all are the problems with, again, function point or the feature points. So out of this four, what we have discussed, LOC is anyhow very simple. So from COCOMO, basic, intermediate, complete, and then function point and feature point, you will at least get 2 questions of 10 to 15 marks in your exam. Fine. So we'll continue with this next lecture. Any question, anyone? Clear about line of code, constructive cost model, function point and feature point. It's all about equations. What you have to remember, put up the values, right? And you have to calculate the cost. You have to calculate the efforts. So once you get function points, total number of function point, per function point, you can define 1500, 2000 and then multiply. This is how you can get the overall cost of the software. So either you can use COCOMO for calculating or estimating the cost of the software, or you can use function point, right? Industry standard is function point. Any question?
No, sir.
No, sir.
Okay, so I have already circulated this PPT. If you wish, I can resend. So you can today only refer. And if you have any doubt, let me know in the next lecture. So I am circulating this PPT right now only so that you can start referring. Okay, so I am sending this PPT right now only.
Sir, it's 19 BCA, sir.
सॉरी, अरे 18 कर दिया, 8 सम चले गया भाई, सॉरी 19. Okay, so kindly go through it, and if you have any problem, please let me know. We'll discuss it out. Shall I stop then?
Yes, sir.